So this is another example on convolution. So this one was sent to me by one of my subscribers. So thank you for sending this my way. So we're gonna try to solve this one. But I would suggest you, if for those of you who haven't seen convolution problem 1 and 2 under the videos, I would suggest you to watch those, because I would probably skip some steps here, because I would assume that you already sort of understand a few of the steps already. Alright, so we do have two triangles here that we are trying to convolve. I haven't really done anything at all. I just draw I made it bigger so that we can see when we do the overlapping and things like that, so we can kind of see it. But that's all. I haven't started shifting or anything like that. So we do have two triangles here, and they're the same, so we don't really have to make a decision on which one we have to flip or not. We can flip either one and it would be the same thing anyway. So it goes from 0 to 2, and over here we have a 1 here. So we can keep x of tau, x of t, and then we can shift h of t. It's the same thing anyway. So the first thing we have to do, again, is to change the t's to tau's, which will, because we are trying to multiply the two functions, so we have to change the t's to tau's. So once we do that, let's go ahead and do it. Once we do that, then we're going to start flipping. Alright, so this becomes a tau. This is a tau as well, and this is a tau, and that's a tau. Alright, so we decided to maintain x of tau, and this is what I draw here. We are shifting h of t minus tau, and so if we multiply, before we do that though, if you notice one thing, that the triangle is really what it is two straight lines. Okay, what I mean by that is when we do the overlapping, we are going to have to multiply functions here, and so it's really important when you have a triangle to identify the lines, because we have a line here going from 0 to 1, and we have another line here, so it's important to put the equations of the line. Okay, so here we have it starts from the origin, so the equation of the line here, this one right here, that's just tau. That's the equation of the line, so we can put a tau here. Okay, the equation of this line over here is 2 minus tau. Okay, I don't know if I should go over how to find equation of line. That's pretty straightforward, right? You just sort of find the slope of this line, and you have to intercept here at 1, and you got a number here also. The y-intercept is 1, so it's pretty straightforward to find the equation of this line over here. Okay, so if we flipping, now we go to h of tau. If we flip h of tau to this side over here, I'll show you, and I will delete it afterwards, erase it. So if we flip it by minus tau, this is what we have. This will become minus 1. Okay, we have a minus 2 here, but this equation would be 2 plus tau, because you're multiplying by minus 1, right? We are multiplying by minus 1, so this 2 minus tau will become 2 plus tau. This is a 2 plus tau. It's a positive slope, and then this becomes a negative slope, so this is going to be a this is going to be a minus tau. It becomes a negative slope. Okay, now if we shift it by t, because we have to shift it by t in order to get ht minus tau, that's what we're trying to get here. So if you shift it, what you're adding is a t here. Like say for instance you want to shift it to the left by -3, for instance. If you shift this by -3, your point over here would change, right? And your point over here also would change. In order to get that negative, you would have to add a t. Okay, you would have to add the t, so it would be minus t here, but it will be a plus t here. Okay, so that's what we have here. I'm hoping that you're following what I'm saying here, because if it can get confusing at this particular point, because you're like, okay, why do I have to subtract here a minus t and add a t here? But what it is that you're talking about the y-intercept. Let me do this real quick so you can see why I'm doing that, and I will erase that. Because if you have a line over here, if you have this one, for instance, if you have a line over here, the equation of this line, let's put x so you can see it. So this is a 2 plus x line. All right, let's say this is a -1 here, and this is a -2 here. Okay, because what it is that if x is equal, let me try to show you how I found the equation of the line first of all, because I think I've sort of skipped that part. If x is equal to -2, your y is 0. If x equal -2, y is 0. But if x is equal to -1, y is 1. X is equal to -1, y is 1. And then you find the slope m, which would be 1 minus 0 is 1, and this -1 plus 2, it's a 1. So you have a positive slope already as 1. And so your equation of line becomes y is equal to mx, m is 1, so x plus b. So if x is equal to, for instance, -2, if x is -2, your y is 0. So your b becomes 2. That's what we've done here. So the equation of the line becomes x plus 2 or 2 plus x. That's why we have this line here becoming 2 plus x. Now, what I really wanted to show you is if you shift it, for instance, if you shift this by t, let's say t is going to be a negative number. T is definitely going to be a negative number. So if you shift it by -3, for instance, what we're going to have is, let's erase this. If you shift it by -3, for instance, this will become, let's say this will become -3, and this will become -5. -3, and this will become -5. In order to make this part of 5 here, you would have to add the minus number here. It would have to be a 3. And in order to make it a 3, it would be minus t, minus t. And that's what we did here. And that's why the equation of this line becomes minus t. And you do the same process here in order to have minus t plus t, okay? All right, so we have the equation of those lines there. Now we can start our shifting process. And if you have questions on that, you can let me know as well. But I don't want to make this video long. That's why I'm kind of skipping steps here. Alright, so now your equation will become that way. So you have a t minus tau here. So this will be a t minus tau, and you got a t minus tau here, and you got a t here. Okay? Alright, so this is what you have at the end of the day. This is what you have. We haven't started the shifting yet. We're just flipping and doing the h tau, t minus tau. And so you have a t minus 1 over here. You have a t here because you shifted it at t. You got a t minus 2 over here. And your equation of line becomes 2 plus tau minus t in this case. And then this is a negative slope, so this is a minus tau here, plus t, plus whatever here, because you're dealing, this is at the x-intercept, so you're not changing anything, but this is at the y-intercept, so you're changing it to minus t. All right, so now we can start. Let me erase this real quick. Oops. Okay. So the yellow triangle is your ht minus tau So your yellow triangle is, this is your ht minus tau, and this is your x of tau. That's what it is. Okay, so this is the fundamental start of the convolution. Once you get these, everything else becomes extremely easy. You got your limits, you got your equation of your lines. Anything else is just finding out the integral under the area of that. You're just multiplying, basically. It's just a multiplication. It just becomes a multiplication of that. So we can start shifting now to the left, because this is, we are maintaining x of tau, and we are shifting this. So if you shift it by t, there's no overlapping. So when t is negative or whatever, there's no overlapping. So I'm going to skip that part. And so let's start moving it to the right. So let me erase that part and start moving it to the right. Okay. Again, there's it's a t, I mean it's a 2 plus tau, those equation. I'll rewrite it anyway. So the first one is, there's no overlapping if you move it by t. So now we are over here. The first overlapping, let's say over here. Okay, so this was your t, and this is not at the origin though, so this is a t. Again, I'm skipping finding out the overlapping regions, etc., because we're not really finding the final graph. We're just finding the integral part of it. So this was your t minus 1, and this is your t minus 2, and this one was 2 plus tau minus t, and this is your minus tau plus t. So what it is just the equation of this line over here, and then the equation of this line over here. All right, so your overlapping region is this area over here. This is your overlapping region, and this is bounded by you multiplying x of tau and ht minus tau. So this is what you have now. Your ht minus tau is this line over here. So your integral on that particular part is your integral on that area is goes from 0 to t, right? 0 to t, and you're multiplying x of tau. X of tau is your pink line, so your x of tau here is tau, so you have tau, and then your ht minus tau is the bounding this one, so minus t plus minus tau plus t, minus tau plus t, or t plus or t minus tau. So you just solve for this integral and you get your first region of overlapping. And this one actually occurs when t minus 1, or when t becomes positive, right? But to the point where you're not actually getting into 1, so less than 1, and t minus 1 also is less than 0. You're not entering here. So those are going to be overlapping region, but we're not graphing this, we're just trying to find the integral, because that was the question really here. Okay, so again, you're looking at this line over here because you're multiplying them. This is not a this can be anything really. So you're multiplying x of tau, which is the line over here, tau, and then you're multiplying h of t minus tau, which is minus t minus tau plus t. So that's your first overlapping integral or whatever. Now we can move forward as well. So let's erase. Okay, so let's keep moving with the yellow. H of tau minus h of t minus tau. So now we move the triangle again. So we are going to be somewhere here where we're not crossing the point of origin. All right. Okay. So this is still your t minus 1. This right here would be your t, still your t minus 1. This is still your t, and this is still your t minus 2. And again, this equation of this line, the equation of this line is 2 plus tau minus t, nothing changes there. And then the equation of this line is minus tau plus t. Okay, so your overlapping region is this right here. Hopefully you can see it. So this is your overlapping region. That's the one underneath this right here. Okay, so now we can go and find the integral, but as you can see here, it's divided, right? So we have 3 parts, from 0 to t minus 1, from t minus 1 to 1, and from 1 to t. Those are our intervals really. So from 0 to t, the reason why is because of this, the middle, this one right here, the middle line, the one over here. That's why you have the t minus 1. It really is sort of not complicated, but yeah. So from 0 to t minus 1, what do we have? We're multiplying. So that the first one is the first one, so let's just put a line in there, whatever. That's the second one, because the first one, remember, there was no overlapping, so that was a 0. So this is the second overlapping region, and this is the third overlapping region. Again, I skipped the part where we're finding out the actual overlapping region, not the area of overlap, but the region itself where the overlapping occurs. I skipped that part because we're not going to draw the final convoluted signal or whatever. So we don't necessarily, in this particular question, I mean, if you had to do it, then you would. What I'm saying is finding the overlapping region would be saying that overlapping occurs at t minus 2 less than 0, t minus 1 less than 1 and your t less than 2, etc., etc. That's finding the overlap, but we're not doing that. I skipped that part. If you want to find out how to do that, you have to watch the first video so you can see, have a feel of that. Okay, so here we're just finding the actual area underneath. So again, what are we multiplying here? X of tau, h of t minus tau. So from 0 to t minus 1, from 0 to t minus 1, what do we have here? 0 to t minus 1, we have our, this was, I deleted this, I erased that, but this was tau, this was tau. So if you multiply from 0 to t minus 1, the area would be the multiplication between x of tau and ht minus tau. So x of tau is tau. X of tau is, why am I changing colors like that? But anyway, so x of tau is tau, and then we multiply h of t minus tau. In this case, that would be this line over here, 2 plus tau, blah blah blah. So we have 2 plus tau and t, whatever. Okay, so that's what we have in that case. Now from this one right here, from t minus 1 to 1, t minus 1 to 1, t minus 1 to 1, what do we have? T minus 1 to 1, from t minus 1 to 1, we have tau, we have x of tau would be this one right here, because we are underneath here, right? This is where we are. So our x of tau is this, which is tau. Okay, but what's our h of t? What's our h of t is the yellow line over here, which is minus tau plus t. Minus tau plus t, or t minus tau. Okay, let's keep going. Probably would have to draw another one though. Okay, so the third one would be from 1 to t. So we have 1 to t. What do we have? So we are here 1 to t. What's our x of tau in that case? X of tau again is our pink line. So from 1 to t, 1 to t, we have 2 minus tau. We have 2 minus tau, and our h of t minus tau in this area, in this region right here, the yellow line is minus tau plus t. I hope you understand what I'm doing though. Minus tau plus t, or t minus tau, whatever. Okay. Final overlapping. I probably shouldn't. I won't delete that. I won't erase it. I'll just draw another one, because then it will probably. Yeah. Let me just draw it here underneath. So. Alright, so I just drew that x of tau. Now we can draw the yellow one, which is the one that's actually moving, the h of t minus tau. And so in this case, remember this one was before, that was before 2, and now this one would be after 2. It would be after 2, and then this would be here. So what we have here would be sort of like this, because we're moving forward. So that would be like that, like this. Okay, whatever. So now this is our 2 plus nothing changes, minus t, and then this would be minus t plus tau, still the yellow one, plus t, and then the middle one here is our t minus, this would be our t t minus 1, and this would be t minus 2. Oops. Alright, so what we have here would be, so we're just going to follow the rules, same thing. Just keep going and following the integral part of it, which would be, I'm going to draw a line here, whatever. Okay, this should be purple, but okay. So what's our area of overlapping? Obviously we can see it, it's here. This is our area of overlap. This is what they have in common. Okay. So, but it's divided in 3, right? So we have from t minus 2 to 1. So the first one would be from t minus 2 to 1. From t minus 2 to 1, x of tau, which was the pink line, is tau, and our h of t minus tau in that area is 2 plus tau minus t. 2 plus tau minus t. Okay, delta tau, of course delta tau, we're integrating here. Alright, so we can keep moving as well. 1 to t minus 1, that's our second one. 1 to t minus 1. What do we have from 1 to t minus 1? What's our x of tau in that case? X of tau in that region is going down the slope. So it's the t is the 2 minus tau. So we have the 2 minus tau between here 1 and t minus 1. Because you're multiplying two integrals. Again, you are multiplying two integrals. You're multiplying x of tau, and you're multiplying x of tau times h of t minus tau. The yellow one is our h of t minus tau, and the pink one is our x of tau. So x of tau between 1 and t minus 1 here, forget about this part because it's not underneath that region. So the only thing you have in that region is 2 minus tau. That's what we have here. Okay, so for the yellow one in that area is our between 1 and t minus 1, between 1 and t minus 1, what do we have here? That's t, that's the 2 plus tau minus t, delta tau. And then the final region, the final integration part would be between t minus 1 and 2, t minus 1 and 2, and in that case the pink line between here is 2 minus tau, and the yellow one, which is our h of t minus tau, in this area is minus tau plus t. So it's between yellow and pink. You're just kind of looking at minus tau plus t, and then you just integrate and just integrating and figuring out the actual equation. You just multiply out and then replace just like a normal ordinary integral, and that's it. Now I highly doubt you would get this during the exam because it's pretty long, but I mean you can, but they won't ask you the whole thing. They probably would ask you one of these interval between that and that, what's the integral, or the the final graphical whatever, which we haven't gotten into. But essentially, when you have two triangles, the key word here is to find the equation of the lines and finding out the overlapping area, and then just multiplying your x of tau and your h of t minus tau. That's the key here, multiplying that. That's what we've done here. So whatever the line underneath that region is, that's what you're taking. And that's why it was really, really important to find the equation of this line.